here are using Redux on a day-to-day basis? Oh, lots of people. Cool. Okay, so before I start talking about Redux, I want to talk a bit about async. What makes something asynchronous? So the first thing we need to know about is what synchronous is. Synchronous is when you do something one line at a time. Asynchronous is when you start one thing, and then while that thing's running, you go start something else. So you're kind of juggling multiple things at a time. Now, JavaScript is a single-threaded language. If you don't know what this means, don't worry. But basically, what it means is that you can really only do one thing at a time in the JavaScript language. There's this concept in most JavaScript engines called a call stack, and it's a stack of your currently executing functions. One thing you should know about the call stack is that if you have a function on it that happens to be very long running, you have a while loop with maybe 1 million items in it, that creates something called blocking behavior. So you have this long running function, a user's trying to click on a button and nothing's happening, that's blocking behavior. Again, about JavaScript being single-threaded, here's a diagram of an average browser engine. This is like a diagram of the V8 engine. So you see you have your stack there, which I just talked about, but you also have these web APIs that allow you to do asynchronous things. For example, you'll make a network call, and when the network actually comes back with a response, it takes a function called a callback and pushes it onto the callback queue. That function doesn't actually get run until the stack becomes empty enough. Once the stack has enough capacity, a mechanism known as the event loop goes and gets a callback from the callback queue, also known as the message queue or task queue, and it puts it on the call stack, and that's when your code is actually run. That's when your function is called back. So because of this event loop mechanism, that tiny circle on the page, that's what actually allows you to do asynchronous stuff in JavaScript. So even though JavaScript is single-threaded and you should technically only be able to do one thing at a time, because of the event loop and all these web APIs, you can actually do multiple things at a time, and it gets queued up waiting to happen. Once your stack becomes empty, then you can actually run it. The next thing I'm going to talk about is how you can do async in JavaScript. So one thing I want to clarify is that there's this concept called asynchronous programming, but there is also a feature coming up in JavaScript called async await, and those are two separate things. So it's a little confusing because there's like asynchronous programming, which is a sort of computer science term, but there's also async await, which is a feature of the JavaScript language that's coming out soon, probably a year from now in browsers. So the first thing I'm going to talk about are callbacks. Callbacks are the first thing that kind of came out. For example, this is a network call, you're fetching some API, and then inside you pass a function as a parameter, and that function is called back once the API comes back with a response from the server. I think one thing, if you're new to JavaScript or you're coming from other languages that makes callbacks really confusing is you have this out of order execution. So I think when we write code, it's natural for us to think about it running from top to bottom, one line at a time. But because the way callbacks work, your code runs in this weird out of order fashion. You see the third console log, that doesn't happen until maybe a minute later, which can be kind of confusing if you're new to JavaScript or you're new to languages that use functions in this way. Another thing you're probably familiar with if you've done a lot of JavaScript development is this concept known as the pyramid of doom. There's just a lot of nesting. There's a lot of like curly brackets, and your code becomes very hard to read. If you're a seasoned JavaScript developer, you've probably seen this before, but at the same time, no matter how many times you've seen it, it's hard to read, and it's time-consuming to like figure out what's going on. So another thing that I kind of want to talk about is how callbacks are hard to debug because they're not on the stack. They're on the queue and they get moved to the stack. So sometimes it's hard to see the entire chain of what happens unless you press this little checkbox in your browser. And then once you do that, you will be able to see your entire call stack for stuff like promises or timeouts. I feel like this is not a fully documented feature of Chrome DevTools, so I just wanted to point it out. The last thing about callbacks that makes them kind of hard to use is this concept called inversion of control. So here, this is a bit of contrived code, but you have a tracking code maybe from a third-party library, and they're tracking something, and then after that, your app starts, right? The problem with code like this is that you're giving your callback over to someone else, and it's possible that they might never call that function, or they could call it too late, or they could call it too many times. So imagine if that function is start running your app, you can imagine how things will go wrong, right? So that's my summary of callbacks. Next, I want to talk about promises. So promises were this thing that were invented to solve the problems of callbacks. Promises are immutable, which means they can only resolve or reject once. So promises, like problems like calling a callback too many times, that just doesn't happen with promises. They also have different states, like pending, fulfilled. If your promise comes back with something, it's fulfilled. Rejected, if you do a promise that's a network call and it comes back with 500 error, that's rejected. It also has two functions, then and catch, to handle these states of fulfillment and rejection. You can also do parallel-ish stuff with promise.all, and you can also handle race conditions, race in the sense of like, I'm looking for an API call that returns before other API calls. You can do that with promise.race. Here is an example promise, just to show you what it looks like. Once your promise resolves, you can use a function called then. People call them venables, and you can handle like what happens in your promise after it resolves. So there's a few things about promises. One of them is that there's many implementations. I've listed a few here, but I think I did a quick Google search, and there are at least 15 promise libraries out there. And that makes things super confusing for people. You might get used to a certain promise library and then get put on another project that uses a completely different promise library. Promises like callbacks, they still suffer from a lot of nesting, which can make them hard to read. What to do inside of your then function is also very confusing and not fully documented. And I think another key thing, depending on what kind of app you're writing, is that promises have no cancellation. So if you have an app where you're trying to run some background task and then you need to stop it, you can't do that out of the box with promises. I just want to talk about then or thenables really quickly. I think one thing that was really hard for me when I was learning promises is that I didn't realize when you're chaining thens that you actually have to return stuff from your first then in order to get it in your second then. So I just wanted to point that out as a weird gotcha when learning promises. Next, I'm going to touch on async await. Async await is stage 4 right now, which means it's pretty much going to come out in browsers. I think people have decided that. Right now, you need Babel to like use it. And the other thing about async functions is that they're just promises under the hood. So what you're looking at here are promises, but without the nesting and without it being hard to reason about. When you use that expression called await, that line doesn't run until everything has like been resolved. So again, under the hood, they're just promises. They contain await expressions. Awaits wait for everything on that line to like be returned, then it runs the next line. Again, because async await is just promises under the hood, there's no way to do cancellation. If that's something you really need to do, you can do them with promises. How many people here have used generators? Oh, it's quite a few. Okay, so for me, I started reading about generators. It looked a little bit confusing, and then I just kind of dropped it. And I felt a little bad about that until I saw this tweet from the creator of Redux and realized he tried to implement middleware using generators, and then he sort of quit. For people who haven't used them, generators are just functions. They're a little special in that you could start, pause, and restart them. You can return more than one thing from a generator function using a yield keyword, and they begin with a star. Another thing that is a little confusing about that star is that star can be close to the function keyword, and it can also be close to the name of your function. And the other thing is, when you call a generator function, it doesn't work like calling a normal function. Instead, it returns a generator object that has a function called next on it. And every time you call next, it gives you what you get from the yield keyword. So why are we using generators? Again, like async await, the code is easy to reason about. It only runs one line at a time. It runs, your yield runs, and it waits for all of that stuff to return, and then I'll run the next yield. But unlike promises and async await, you can pause and cancel execution of code in generators, which is really, really useful depending on your application. And like promises, you can run multiple functions in parallel. Cons of using generators is that most of the time you don't use generators without third-party code. So I think a lot of people look at learning generators and they're like, I'm not really sure I can use this. And the answer to that is most people don't use it without a library to help them use it. The other downside is that it's a lot of new concepts if you're a traditional JavaScript developer. If you're coming from another language like C# or C++, you're probably familiar with generators. But for JavaScript developers, it's a lot of new concepts. So how does all of this relate to Redux? I'm going to play this. I stole this image from somewhere, so I have to deal with this animation. Before Redux, we had the state of our application in many places. Traditionally, on the front end, we tried to use MVC or MV type of architecture. We would have models, and these models would model our data for our views, and we have multiple models, maybe all over the place. If we used Angular, we had services that kept our data, and our data was kind of in multiple places. Our data could go in more than one direction. So Flux came around and said, hey, maybe we should have our state in mainly one kind of place, and let's have our data flow in one direction. Maybe that'll make things simpler. And then Redux came around, and Redux decided, hey, let's just put all of our application state in one object and keep it really, really simple. So this is like your basic sort of Redux architecture. You have a view, you maybe click on a button or something, it dispatches an action. The action gets run through any middleware in case you want to do something to your action on the way. And then that gets sent to a reducer, which then updates your state. The benefits of using Redux is your code, it's really easy to follow the flow of data in your application because data only flows in one direction. The other benefit is that it has really great debugging tools, and it's really easy to see all your code at once, or your data. But because Redux is predictable, doing async is complicated in Redux, because async is complicated. There's 4 different ways to do it, and there's also, async happens in this sort of unpredictable way, right? It happens when it happens. You're waiting for stuff to happen, but you can't control when it happens. But Redux is striving to be very predictable. Redux uses middleware to handle async, and there's many different middleware options. As every Redux developer knows, you usually handle your async stuff in your actions, unless you're using Redux loop, which I'm not going to talk about for this talk. So again, just back to the diagram, here are your actions. And here's the different middlewares you can use. I'm going to cover the top 3, which is Redux Thunk, Redux Saga, and Redux Observable. But just be aware that there are many, many others. I'm not going to talk about them. I'm just going to focus on the top 3. I did a bit of an informal survey. Most people are using Redux Thunk, but Redux Saga is also pretty popular. Another thing that I discovered is Redux Saga is actually backed by the creator of Redux. He thinks his own implementation of middleware is suboptimal compared to Redux Saga. Async Action Creators is another word for Redux Thunk, which is the library that he wrote. So I'm going to do a little summary here. I'm going to talk about Redux Thunk first. So Redux Thunk has quite a bit of documentation, but the actual library is only 14 lines of code. It's just a function that returns a store dispatch and store get state. And it can handle parallelish stuff and also raise conditions in terms of which API call returns first. You can also use async await in Redux Thunk to reduce that level of nesting. Here's an example of using async await. The downside of Redux Thunk is testing is a little on the painful side. You have to, this is an example test for a network call, and you have to mock your request and mock your response, and then check to see if all those actions returned, which is pretty time-consuming. Next, I'm going to talk about Redux Saga. Redux Saga is just generators under the hood. So they have all the benefits of generators I just mentioned. You can run stuff in parallel, you can handle races, you can cancel if you need to, but also you get the benefits of stuff that looks synchronous even though it's working in asynchronous fashion. Redux Saga has this thing called effects helpers. If you haven't used sagas before, it's sort of a weird concept. But for example, when you make an API call in Redux Saga, you aren't making the API call. You're telling the Saga middleware to go run the API call for you via these like effects helpers. It's a little confusing, so I'm going to show a code sample, but this makes testing really easy. And once you learn the API, the code is easy to reason about. So here's an example effects helper. You have a call, and then okay. When you you call that effect helper called call, and then you're telling the Saga. Sorry. Okay, so back to this effects helper, which is call. So when you have a yield in a generator, it yields whatever that line is doing. And in this case, the effects helper is yielding an effect, which is just a plain JavaScript object. The best part of this, it's a very simple JavaScript object. It's very simple to test for. You can just test it using to equal, right? So this is an example test code for like a basic API call. I just want to contrast it with Redux Thunk. As you can tell, you're writing much less code. It's easier to read, and it's faster to write your test code, which makes writing tests more fun. So the downside of Redux Saga is the community isn't as big, which means that if you run into problems using it, you're not going to get as much help, which kind of sucks. Like, we've all been there, we've used a new library, and like, we have a question, there's just no answer, right? It is getting more popular though. The other problem is the API is not reusable knowledge. So once you learn the Redux Saga API, you read through all the docs, it's not like knowledge you can apply to like other libraries. Also, the surface area of Redux Saga is just bigger than Thunk, so it takes you longer to learn in general. The last one I want to talk about is Redux Observable. It's really easy if you already know Rx, like RxJS or RxJava. It's still kind of easy if you use Lodash all the time. It has some built-in features like throttle and bounce to help you write autocomplete and drag and drop components. But again, this is like not a big deal if you're already using Lodash. You can just use Lodash with Redux Thunk and kind of get the same effects. My observation using Redux Observable is the testing is still a work in progress. The docs are currently being rewritten to make testing more comprehensive, but from what I can see, you still have to mock your request and response. So I think your test code will, at this point, look similar to Redux Thunk. So in summary, I think most of the time you can use Redux Thunk, but if you're on a long-running application and you need to write a lot of test coverage, tests are very important to you, I would seriously take a good look at Redux Saga. If you need cancellation, for example, you're using like WebSockets and you need to like turn them on and off, I would take a look at Redux Saga. And if your development team is coming from other languages that use generators, C#, C++, etc., I would also take a look at Redux Saga. Thank you for listening.
Got some couple questions?
Yeah.
Hi, my name is Destiny. My question is just, we are doing Angular, Angular 2, Angular 4 application. Is there a suggestion that we should do?
Well, I haven't used Angular, like the new version of Angular very much, but I know that you can use Redux with it. But like, I heard that it uses a lot of observables already, so I don't like. I guess I would look at the testing. Like, if you think the way tests are currently run with Angular 4 without using Redux looks kind of painful. I would like really take a look at Redux Saga. So, the person up there.
One of the work I've seen with Redux is to create like your own API middleware, so that when you create an action, you have like a special property that your middleware recognizes and then it makes all the calls for you, and that like reduces your action creator code. I was wondering if you could try that approach and what your approach like that.
I think we use that a lot here. Like we'll sort of write like an API object with its own like fetch and like put and stuff. We do it and it's like easy to implement. We're not always writing tests for it. So I guess like you could write tests on your API side and then like you can write thunk tests and then maybe write tests for your API object. But like I find that like when tests are hard to write, people are less likely to write them. I guess that's my takeaway. Oh, thanks. I have to find out about that because I'm actually doing this talk in a month again, so I might put them out after that. Yeah, hopefully soon. Cool. Awesome.